Have you ever thought about how much energy we create just by moving around? Imagine if every step you took, every car that drove by, could actually help power the world around us. It sounds like something straight out of a sci-fi movie, but the tech is real, and today we're going to dig into it.
I mean, just think about it for a second. The sheer kinetic energy in a busy city. Thousands of people walking through a subway station, cars driving down a highway, crowds at a concert. It's a constant source of motion. What if we could actually capture that? What if every single footstep could help light up the streetlights overhead?
Well, one of the most promising answers to that question is a technology called piezoelectric tiles. And in this explainer, we're going to pull back the curtain and see exactly how these things work, what they're capable of, and maybe what they're not. Okay, so to understand how an entire floor can generate electricity, we've got to zoom way, way in. We need to look at the tiny little spark that's at the heart of it all. You know that click when you use a barbecue lighter? The one that makes the spark? Well, that's not a battery. What's actually happening is you're using a spring to slam a tiny hammer into a special crystal. That physical impact, that's what creates the electricity for the spark. And that whole phenomenon has a name, the Piezoelectric Effect. It sounds complicated, but it's not. The name literally comes from the Greek word piezo, which just means to press. And that's all it is. You press on something and you get an electric charge. Simple as that. So let's get down to the molecular level. Inside one of these special crystals, you've got positive and negative charges, and they're all arranged in this perfect balanced structure. When it's just sitting there, everything is neutral, no charge.
But then, you squeeze it. You apply pressure, and that physically squishes the crystal's internal structure. It deforms it, and that forces the positive charges to one side and the negative charges to the other.
And that separation is the magic moment. Suddenly, you have a positive side and a negative side. You've created an electrical imbalance. And that difference between the two sides, well, that's a voltage. You've literally created a tiny burst of electricity just from a squeeze. Okay, so we've got the basic science down. A tiny spark from a tiny crystal. But how in the world do you scale that up into something you can actually walk on? Let's look at how they build one of these tiles. It's really like a high-tech sandwich. On top, you've got the durable surface you step on, usually something tough like recycled rubber. Right below that is the engine, the piezoelectric material itself. Then you've got the circuitry that grabs that little electrical pulse and gets it ready for storage. And the whole thing is wrapped in a tough protective case. So, one tile on its own? It's not going to do a whole lot. The real power of this technology, the whole point, isn't about a single step. It's about millions of them. It is all about scale. And this isn't just theory, they've actually done it. Way back in 2008, a train station in Tokyo installed these things. Get this, with around 400,000 people walking over them every single day, they generated enough juice to power the local LED lights and some digital signs. Pretty cool, right? Footsteps are one thing, but they're relatively light. What if you could harness something much, much heavier and more consistent? Yeah, I'm talking about traffic. Cars, buses, and especially trucks. A 2014 study looked at just how much energy is being wasted on our roads, and the idea is pretty straightforward. The heavier the vehicle, the more the road deforms, and the more potential energy there is to capture. And the numbers are kind of staggering. The study calculated that on a single kilometer of one lane of a busy highway, there's up to 150 kilowatts of potential energy available every single hour. That is a huge amount of energy that right now is just being lost as heat and vibration. Okay, the potential is obviously massive, but potential energy and energy we can actually use are two very different things. So it's time for a little reality check. Let's separate the hype from the real harvest. So let's put these tiles head to head with something we all know, solar panels. Now, Piezo has a huge advantage. It works 24/7, rain or shine. But here's the catch. The power you get per square foot is really, really low compared to solar. And right now, the costs are pretty high. It tells you they're just built for very different jobs. And here it is, the bottom line. One single step generates just 1 to 10 milliwatts. That is a tiny fraction of the power you need to even boil a kettle. So the idea of powering an entire city this way, well, we're just not there yet. It's not practical. But this is where the story takes a really interesting turn. What if we've been asking the wrong question? Maybe the goal isn't to power our cities with our streets. What if the real goal is to make our cities smarter? This is the technology's real superpower, not generating massive amounts of electricity, but creating tiny, self-powered sensors. Imagine a floor that knows how many people are in a building to control HVAC, a bridge that can monitor its own structural stress, roads that track traffic flow in real time, all of it powered by the vibrations they're already experiencing, with no batteries, no wires.
So that leaves us with this final thought. What if the true revolution here isn't about replacing power plants? What if it's about creating an intelligent, responsive world that harvests data from the energy we were already wasting anyway? Now that